y equals 8,000. So y must be 5,000.
Okay.
So it's really impressive that you're able to set these up, because that is in some ways, if you can't do that, you mean you're just totally stuck.
Yes.
Okay, so 40, have you tried 40, or is that one we need to work out together?
So 40, I just started working on 39 right now because I was
Okay,
kind of waiting for you, but it's all right.
no, that's okay. It's really similar. Okay,
Yes.
it says a retired couple invested part of $12,000. That means they have $12,000 total at 6% interest, and the rest at 7.5% interest. If their annual income from these investments is $810, how much was invested at each rate?
Okay.
So it's really similar. Like
So,
there's a total equation, and then we got to
mhm.
deal with the interest rates. Sorry, go ahead. You probably want to.
So x plus y equals 12,000
Okay, agreed.
and 0.06 x plus 7.5 y equals 810.
Okay, you got it.
Okay.
Okay, so let's do this one using substitution, only because I want you to get practice with it, not because it's the better option. I think elimination would be
Okay.
better. But let's solve this first one for y. So y is 12,000 minus x. You're just subtracting x from both sides.
Okay.
Okay, so now that 12,000 minus x is going to go in wherever you see a y. Remember that from the other day?
Yes.
Okay, so it's 0.06x plus 0.07y parentheses 12,000 minus x equals 810.
Okay.
What do we do here? What's the next thing to do to solve for the variable?
So you go with the parentheses first?
You distribute that 0.075. You're going to distribute that into both of these.
Mm-hmm. And then multiply both sides. Or distribute, sorry. And then
Okay, so it ends up being 900 minus 0.075x equals 810.
oh, wouldn't the decimal be 7.5?
You have to convert percents to decimals, just like you did the 6%.
Oh, okay.
You
I
said
just thought it was
point
already
oops.
a decimal. Okay.
Oh, I see. Oh, well, yeah, well, it is. It is. It's 7.5 is a decimal, but to go from a percent to a decimal, you always divide by 100. So it's
Okay.
7.5 divided by 100. And you learned, and maybe it's just a good refresher, that means you move the decimal left 2 places.
Okay.
It's a good question, good comment, because you're right, it is a decimal. It's just not.
Okay, thank you.
Okay, so now we're at a line where we need to combine like terms. The 0.06x and the minus 0.075x. What do
So
those
would you, yes, they do combine.
Yes, so what do they combine to? And again, if you're allowed to use calculator, just use that, or if you know the answer, you can tell me.
Negative 0.015.
Yes, x
Okay.
plus
X.
900 equals 810. Good, doing great. There's a lot here, obviously. So what?
So would you
What?
subtract negative 0,
Nope,
15 from both sides.
nope. You look at the side with the variable. The variable's got two
Okay.
things going on. It's got this addition by 900, multiplication
Uh-huh.
by minus 0.015.
Okay.
And this may be why you avoided this. So when you're simplifying, you go this way, but when you're solving, you go backwards. You undo addition and
Okay.
subtraction before multiplication and division. So that means you're
Okay.
going to
So you
subtract.
subtract 900 from both sides.
Yes,
Okay.
yes. So you have minus 0.015x equals negative 90.
And then you divide both sides.
Divide both sides by minus 0.015. So what does x equal?
6,000.
6,000, yeah. And then what is y equal to? Go back to the original equations you set up.
Mm-hmm. And y would equal 6,000.
Yes, good.
Okay.
All right, so that's 40.
So what was it called again when both equal the same number? Isn't there a name for it?
You're thinking of maybe something from a previous lesson where we talked about it, them
Oh,
being,
okay.
the answers being like infinite solutions.
Okay.
Good
Maybe that was
memory.
for graphing, I think.
Yeah, but
Okay.
appreciate you asking because it does seem odd that it would be the
Okay.
same. So, all right. I got a lot to say about money, but not in this lesson. We got to solve some systems. So, all right. So, like here's probably one where you're more likely to need a calculator,
Mm-hmm.
because the other ones maybe could have done without it. But a woman invested some money in a credit union, paying 5% annual simple interest, and 3 times as much in a money market account, paying 4.25% annual interest. If she earned $1,420 interest in 1 year, how much did she invest in each account? So the difference
Okay.
between this problem and the previous one, and sometimes it's good to read it twice, is you don't get the total. It doesn't say like she invested a total of $10,000. Okay. It
Okay.
says that she invested some money at 5%. Okay. And some other money at 4.25%.
Mm-hmm.
Okay, so you do have that. You do have the interest equation. Like what I'm trying to say is you're used to getting a total equation and an interest equation. And this time you're
Yes.
just given the interest equation. Okay, that's the 0.05x plus, what is 4.25 as a decimal, Luis? Can you tell me that?
0.425
So you're
or
dividing by 100,
0.25.
it's 0.425. So if you need
Okay,
to, you
because I
just come
remember
off,
last problem you put a 0 in front of it.
so you're always going left 2 decimal places and you fill in with a 0. And then
Okay.
4.25, same thing. You're going left 2 decimal places. You fill in with a 0.
Okay.
Just make a quick note here in case we get some time at the end to go through this. Some decimal stuff against decimals. And what was a two-step equations? Okay. All right, got it. Now this equals, I'm sorry, y, because that's the second investment.
Yes.
This equals 1,420. Okay.
Okay.
Now there's something encoded in the first sentence. Could you read that first sentence one more time and
A
tell me if you
woman
see?
invested some money in credit union paying 5% annual simple interest and 3 times as much as a money market account paying 4.25% annual simple interest.
Okay. So sometimes there's the total equation, sometimes there's the interest equation, but there's also what I call the relationship equation,
Mm-hmm.
and it's right here.
3 times, yeah.
Okay. And what that means is like let's say well, we know that x is the 5%, but she's doing 3 times as much in the money market account. So here are your possibilities. It's either X equals 3Y or Y equals 3X.
Okay.
Okay. And
Which
so
one
it's
would
like,
be easier?
well, no,
Or they both?
it's, so we're going to use some numbers here. Okay. So
Okay.
let's say it was, well, let me ask this first. Which is larger, X or Y, based on the way this reads?
X.
So 3 times as much in the one paying 4.25%. That's the Y. So
Mm-hmm.
the Y is 3 times as much.
Okay.
So it's either like this. So it's either like this is 300 and this is 100, or this is 100 and this is 300. This is not helping, is it? Okay, let me back up
No,
here.
it's okay. It's okay.
Well, what I'm trying to get you to see is that you have to decide which one it is. And like I can tell you that it's the
Uh-huh.
one on the right. I've done these so many times, it's the one on the right. But what you have to be able to see is that the Y, let me use these numbers, the Y is 3 times as much as the X. So like if
Yeah.
X is 100, then Y is 300.
Mm-hmm.
And this equation on the right does it for you. Because if you put 100 in for X, what is 3 times 100?
300.
300. And so like sometimes there's confusion about which one to write,
Okay.
but this now settles it.
Okay. That makes sense.
We'll do another
That makes
example.
sense.
Hopefully this will come up again. So because it's already solved for, you're going to use substitution in this one. So let me just reframe
Yes.
this with 0.05x plus 0.0425y equals 1420, and y equals 3x. So you're going to use substitution. So wherever you see a y, you're going to put in for y 3x. So that's 0.05x plus 0.0425 times 3x equals
Parentheses.
1420.
Yes.
Yes, in parentheses. Yes, very important.
Okay.
All right. So now um, you have to simplify. So you have to take that 0.0425 and multiply by the 3. So if you
Mm-hmm.
got a calculator handy, go ahead and tell me that.
0.1275.
Good. X. What can you do now on the left side of the equation? What do you know to do here?
You subtract the 0.1275 at both sides.
Well, but you want your variable to be on the left, and it already is. See how they both have an X in them?
Yes.
So you actually combine like terms.
Oh, okay. So now you combine both. Okay.
Yes. So grab your calculator again, add these up, not multiply, add them up. What do they add up to?
0.1775.
X equals 1420. What's the last step here? What do you do to solve for X?
You divide both sides by 0.775.
0.1775, yeah. And believe it or not, that works out nicely. Let me know what you get for a final answer on that.
8,000.
8,000, good. Okay, now you also need to get the value for Y. You have to go back
Yes.
to one of the previous equations and
So
figure
would the
out,
second one be easier?
yes, absolutely, because it's Y
Okay.
equals 3X.
So 3 times 8,000. 24,000.
Yes.
Okay.
All right, 3 questions in. How do you think you're doing? Do you feel like you understand?
Yes, I understand. This one was a little bit harder because it was like
Yeah.
a few more decimals in there, but I think I'm getting it.
Okay, so 42. 42 is kind of like the first two that we did. It's got a total and an interest equation. I'd like you to read it and see if you can set up the two equations for me.
Okay. A teacher started an individual retirement account by investing a total of 30,500 into two municipal.
Municipal,
Yeah, I mean.
you don't have to read them out loud for me. If you want to read it to yourself, that's fine. I just
Oh,
want you to,
okay. Sorry.
yeah, sorry. I should have been clear. I like that you're reading them out loud, but, and I will, but I just want the two equations. So if you want to read in silence, please do.
Okay.
And actually, most of these words aren't important, by the way. Like, it doesn't really matter what it is. So, but yeah, go
Okay.
ahead.
So would it be x plus y equals 30,500? And then the second one would be um 0.05 x plus point. How would you do the second one? Because it's like
Right. So
contraction almost.
so that like this right here is actually 5.5%. The one
Okay.
half is the 0.5. Does that help?
Okay. So then it'd be 0.055
Yes. Y
y
equals.
equals 1,615.
Okay, good. It's really important that you be able to do that. That's the total equation. That's the interest equation.
Okay.
Now, do you want to use elimination or substitution to solve this?
So I've been just working on elimination this entire time. So I think I really like elimination for this, but
Okay, let's do it. So which variable do you want to eliminate, X or Y?
I think X right
Okay.
here.
So what do you multiply the first equation by to eliminate this? It's got to be the same coefficient, but opposite in sign.
So negative 0.05.
Negative 0.05. And it's everything, right? It's the number, it's the other
Yes.
one, it's the other one. Going to my calculator, and we got minus 1525, like that. Okay, so tell me the result once you get caught up here, once you add vertically.
So then you'd take out the Y and
Well, the X's cancel, okay, but the Y's
the
do not.
X's.
The
Oh,
Y's
the
do
Y's
not,
don't. You're right.
because there's an extra 5 there. So again, if you need it's okay. Like if your teacher gives you, it's kind of like I make the joke, like we don't get in our car and push it, or we don't push our car, we get in it and drive it. Like if you're allowed to use a
Yeah.
calculator, just use it. Like use it for everything. We'll
Okay.
we'll, we'll work on getting you faster at non-calculator stuff, but if you're allowed to use it, please do.
Okay.
No, I don't set a fire to make my food. I put it in the oven or go to the microwave.
Okay. So I got 0.15 equals.
Ooh, oh,
Let me just
okay.
do the other one.
Nope, there's no sure. So we're doing the 0.055 minus the 0.05.
Oh, we're subtracting here. Okay.
Well, you're adding, but you're adding a negative, so it is like subtracting.
It is a negative. Okay, I put a positive. So let me just do that again real quick. Would that be 0.005?
Yes.
Okay. Let me just do the second one real quick. $90.
Okay.
Okay.
What's the last step here to,
Divide both sides by 0.005. And then I got 18,000
okay,
for Y.
that sounds reasonable.
Okay.
Okay, and then give me the X value. Go ahead and use one of the equations or the other and solve for
Okay.
X.
X equals 12,500.
You got it. Nice.
Okay.
Really good. Really, really good here. Okay, so we still got, I was gonna say here 43, 45, and 46. Is that right?
Yes.
Okay. Um, all right. I guess we can do these in the order. I just want to make sure we get through all of them. We should have no problem doing that. So let's keep going with
Okay.
40, 43. A lot of money problems today.
Yes, today we were learning about interest and all that. So,
Okay. So I'll read this one for us. Couple stopped using their Visa credit card, charging 1.5% per month in interest. So give me that as a decimal. What is 1.5% as a decimal?
0.015.
Good. And their Robinson's May credit card charging 1.75% per month. Robinson's May used to be a department store. I don't think there's actually any more in existence.
Okay.
Can you convert 1.75 to a decimal?
Yes. 0.0175.
Good. Per month, because they had built up a combined debt of 16,500 onto the two cards. Okay. So that's the total. Think of that as the total.
Yes.
Okay, for 1 month, they made no purchases or payments on the account. If the total amount of interest in the credit card was accumulated during the month was 259.25. Notice how I'm circling the important numbers. The rest of this
Yes.
is not really that important. What amount did they owe on each card when they stopped using them? So the variables here are X and Y again, and it's X
Yes.
is one of the cards. You know, we can call that the Visa if you want, and the Y is the Robinson's May. So
Okay.
there's a total equation and an interest equation. I'd like you to give me both of those, please.
X plus Y equals 16,500
Good.
and 0.015x plus 0.0175y equals um would you just combine all those numbers together since we're not using decimal points or
Nope, nope. Think of it this way. How many numbers are here?
4?
And how many have you used so far?
We've used 3.
So maybe we should use the last one. So sometimes it's that simple. Now there's a better explanation than that, but for now, because we're just trying to get better at writing and solving these things, um,
Okay.
we would use that one. Um,
Okay.
this scenario is something you probably have. I mean, I would hope you don't have a credit card at this point in your life, but this is kind of out of scope. And what I mean by that
Uh-huh.
is like you don't have a lot of knowledge of this, so it's a little bit unfair to ask you about things like this. But nevertheless, it is a problem in your class. So yeah,
Yes.
you got them down. I assume you want to use elimination.
Yes.
Is that right? Okay. Do you want to eliminate X or Y?
X.
Okay. What are you going to multiply both equation? What are you going to multiply the first equation by to eliminate X?
Negative point 101. Wait, no, 0.155.
Good. It's got to be that other coefficient, but negated.
Yes.
Now, one I haven't said this yet, but I always like to rewrite it below, um,
Uh-huh.
because I
Yeah, I
really
kind of
don't
saw
want to.
that.
I don't want to be distracted by like having it in the middle. So if you're not doing that, if you're not separating the equations, please consider that. Um,
Okay.
and then that last one, you definitely got to go to your calculator to get.
Let me just pull that out real quick. Sorry, I'm just writing this down. Um,
And if you ever feel like I'm going too fast or you
no,
need time to
you're
catch
good.
up,
Thank you.
just tell me. This is you're the customer. You dictate what we do in these lessons.
So negative 47.5.
247.5.
247, sorry.
Yes, 247.5.
Okay.
Yes. Okay, now I want you to add vertically. Tell me what you come up with.
So I got 0.0025 for y and
25y equals. Yep.
um 23,450.
Help me out here. What number? What is this first number? What do you see here?
Um, it's a whole number. Oh,
259.25.
that's a decimal. I thought it was a comma. Sorry.
Sorry, my handwriting is not the best, especially
No, you're
later in the
okay.
day.
You're using a mouse right now, so I don't blame you.
Well, it got yeah, but we actually got a digital pen, but um, yeah, please ask because your answer you were about to get was going to be so outrageous. It'd been like the millions or billions.
Yeah.
Um, so try that one more
Percentage.
time and let me know what you've got.
I got 11.75.
Yes. Okay. Finish this one off here. Tell me what you get as a final answer for Y.
4,700 for y.
Uh, sounds right. Yes, that is correct.
Okay.
And then give me the X value.
X equals 11,800.
Good. Very good.
Okay.
Any questions on that? Because we're about to transition away from the money problems.
No, I'm good. Thank you.
All right. Okay, 45. These are the next two problems are the kind of the upstream, downstream, upwind, downwind problems here. So sometimes it's good to draw a picture. Um, so the
Okay.
idea is that if you're going, I think downwind is the easier one. So if you're going downwind, if you're going like to the right, the wind is helping you, it's adding. And
Okay.
if you're going into the wind or upstream, if you're going this way, the wind is working against you. Like if this is you, the wind is helping. If this is you, the wind is hurting you. Does that make sense?
Yes.
Okay. Now, these are what are called distance equals rate. Let me actually spread that out here. Sorry. These are distance equals rate times time problems,
Okay.
or D equals RT.
I think we worked on like one or two problems today during class,
Yeah.
so
Yeah. So I'm
this
going to
kind of
reframe
makes
this
sense.
question. We're going to read it and we're going to look for the scenarios here. So there's
Okay.
a scenario, one for downwind, one for into the wind. So let's read here. The jet stream is a wind current that flows across the United States from west to east. Flying with the jet stream. So when it says with the jet stream, that's downwind.
Okay.
Okay. An airplane flew 2,700 miles in 4.5 hours. Okay. So how far did it fly?
2,700 miles.
And how much time did it take?
It took 4.5 hours.
Okay, so do you see how I substituted those numbers into the equation?
Yes.
Okay. Now, we have to talk about the rate. This is the part that's you're not going to like because this is new.
What is the
And
rate again?
well, it's like if you're getting in your car, you're driving at a certain speed.
Uh-huh.
Okay. So downwind, it's really the following. It's R plus the wind.
Okay. R plus. Okay.
All right. So now we're going to do against or upwind or upriver against. So it's still D equals RT. So it says now against the same wind, the return trip took 6 hours. Okay. So now encoded in that is how far did it go? How far did it go on the return trip?
2,700 miles. Same
2,700
distance.
miles. Yeah. It took longer, 6 hours.
Mm-hmm.
Okay. So the rate this time, though, this is the key difference is it's R minus W.
Okay.
So the wind slows you down. Okay,
Okay.
so the key takeaway from this problem here that I'll summarize at the end, but it's that when you're going downwind or with the wind, it's R plus W. When you're going against, it's R minus W.
Okay.
That's your kind of your key takeaway here. Maybe that's even in your notes. Okay, so here's what we've got. We've got a system of equations. I'm just rewriting them here.
Okay.
2,700 equals R minus W times 6. Okay. So you have a system of equations. All right. Now it's not in a format that you like because you're used to the variables being on the left and the numbers being on the right. So we're going to
Yes.
fix that. We're going to take that first equation and put the 2,700 over here. This is for the first one. And then
Okay.
that 4.5, it distributes into both. So that's 4.5R plus 4.5W.
Okay.
And that's your first equation.
Okay.
Second equation, you're going to put the 2,700 on the right, but you're going to distribute that 6 in there. So it's 6R minus 6W.
Can that be a decimal right there?
No. Where do you see a
Oh, okay.
decimal?
Well, maybe it's just my screen. Sorry.
Okay. Okay, so now we have a system.
Okay.
All right. And what do you want to do to solve this system? Do you want to use substitution or elimination?
Elimination.
Okay. Now this one's not as nice as the others
Mm-hmm.
because you can't just like multiply one by the other. But there is a little thing here that I do think is worth showing you. So I'm just going to move this down a little bit. You should always try this. You should always try to divide everything by that number.
Okay. And what would that come out to?
Well, you
Is it
check to
both?
see you check to see if the one on the right works out nicely. Does 2700 over 4.5 work out nicely?
Let me grab my. 600. So
Yeah, so it does. And then the 4.5s, they cancel.
yes,
So that leaves you with R plus W.
equals 600.
Yeah. Now you can actually do the same thing here with the second one. You can divide everything by
Yeah,
6. And it also works out. You get R minus W equals 450. So now you put your equations, on top of each other. The order doesn't matter now. It is elimination, but notice you can just add them together.
uh-huh.
And what cancels when you add them together?
The variables.
Which one?
The W.
Yes. Yes. So it's 2R equals 1050. So can
And
you
then you
solve that
divide.
for R, please?
Yes. 525.
Good. Now I want you to solve for the wind speed, and you can use either equation.
Okay. W equals 75.
Yes, W is 75. Perfect. Okay, now, like a lot of work there, a lot of things that happen. This is the key takeaway though, this down and against. We're going to use that in the next problem here.
Okay.
Okay, and we're going to go a little faster just to get through it.
Yes.
I know we've got another lesson scheduled at some point, so we'll I guess maybe Wednesday or Thursday, probably Wednesday, and then we can always keep doing this. But new problem here. So it takes a salmon 40 minutes to swim 10,000 feet upstream and 8 minutes to swim that same time portion of a river downstream. Okay. Now there's one kind of little wrinkle to this problem that I guess I don't really care for. Usually they want your times to be in hours, not minutes,
Okay.
but that creates fractions. Um,
Yeah.
so I'm gonna avoid that for the moment. We'll see if it works out. So when the salmon's going upstream, I'm sorry, downstream, that's with the current, it's still this D equals RT. So it's 10,000 feet, but when you're going down, it's R plus W, and the
Okay.
time is 8 minutes. When you're going upstream, okay, it's still the 10,000, but this
Mm-hmm.
time it's R minus W times the time, which is 40.
Okay.
Now, instead of doing what we did in the previous problem, we're going to divide both of these by 8 to start, or divide by 40 to start. And we really hope that that works out. So can you grab your calculator and tell me what 10,000 divided by 8 is?
1,250.
1,250 equals R plus W. And how about on the right? Is 10,000 divided by 40?
250.
250 equals R minus W. So see how much nicer this is rather than distributing in the numbers. You
Yes.
can divide first. Now it only works because both of these numbers were divisible by the other number.
Okay.
So it won't always work. Math's full of exceptions. So let me rewrite the two equations. R plus W equals 1250. R minus W equals 250. How do you want to solve these?
Elimination.
Yes. You can just add them up. Okay.
Yes.
So I want you to add them up. Tell me the value of R.
$1,500.
What is 1,500?
R.
There's two R's though, aren't there?
Oh, you're right. So it's 2R and divide both sides. So 750.
Yes. And then I want you to use that value to find the W.
$500.
Yes, W is 500. Good. Whew. Take a break. You say, I did it. Really good here. Let me stop recording here for a moment.